Let's talk about how to identify transformations. By now we have learned how to translate, reflect, and rotate in the coordinate plane. And in today's lesson we're going to kind of informally discuss how to determine which of those types of transformations occurred by looking at a graph. So in this lesson I'm not actually going to teach you anything new. There's not really any notes to take. We're just going to look at a bunch of examples of transformations and decide what happened. Was it a reflection? Was it a rotation? Translation? What was it? When you're looking at a completed transformation like this, the easiest place to get started is to compare where each of the vertices ended up compared to where it started. For example, P on the pre-image was on the left, H was on the top, and D was on the bottom. And if I look at my image, P prime is also on the left, H prime is also on top, and D prime is also on the bottom. This is a telltale sign of a translation. Because the orientation of the shapes stayed the same, I didn't rotate them at all, I didn't reflect them at all. Since the shapes are in the same orientation, really all I need to do is count how far the image traveled from the pre-image. So I just pick two corresponding points and count the distance, like from P to P prime. From P to P prime, I go to the right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And you can confirm that by looking at the other pairs of points as well. From D to D prime, I go to the right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And from H to H prime, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So all three of these points moved 11 units to the right. That makes it a translation using the rule x plus 11 and y. I didn't move it up or down at all, so I'll just leave y as y. On our next problem, though, you'll see that there is a little bit of a difference in the orientation of these two shapes. H and H prime are both on top, and D prime are both on bottom, but this time P, which is on the left, and P prime, which is on the right, they're not in the same orientation. So this could not have been a translation because the orientations are not the same. Instead, this is a reflection. An easy way to tell that this is a reflection is by connecting each of the corresponding points. H to H prime, P to P prime, D to D prime, and you'll notice that all of the lines are parallel to each other. And that's because that's how reflections work. The line of reflection will always be perpendicular to the lines that connect a pre-image to an image. So each of those red lines is perpendicular to the line of reflection. To figure out where the line of reflection is, you just need to count the distance from one point to another and cut it in half. For example, from H to H prime is a total of 8 units. Well, half of 8 is 4. So I can count 4 inward from H and H prime, and it points towards my line of reflection, which in this case would have to be the y-axis. I want to go back to the previous problem really quick and show you an important difference between translations and reflections when you're connecting their corresponding points. If I connect H to H prime, P to P prime, and D to D prime on the previous problem, you'll see parallel lines again. So why isn't this one a reflection? Well, because look at the length of each of those lines. They're all the exact same length. So each of those pre-image coordinates traveled the same distance to arrive at the image coordinates. Whereas when we connect the corresponding points on the reflection example, each of those parallel lines is a different length. Each pre-image point traveled a different length to arrive at the image point. And that length was contingent upon where that line of reflection was. The line of reflection is halfway in between each of those points. Our next example shows an image that is in a completely different orientation compared to the pre-image. The pre-image had P on the left, H on top, and D on the bottom. But for the image, I have P prime on top, H prime on the right, and D prime on the bottom. So these are all in different spots compared to where we started. And that's because this is a rotation. Specifically, it's a rotation of 90 degrees clockwise. The easiest way to tell how many degrees it went is by counting how many quadrants away it is. Each quadrant is worth 90 degrees, right? Because it's made by perpendicular lines, the axes are perpendicular, so each of those angles is 90 degrees, which means each quadrant is 90 degrees. So from our pre-image to the image, it went one quadrant away, so it must have gone 90 degrees. And we started up here in the top left, we ended in the top right. That is a clockwise movement. It's the same direction that the clock goes. So we would say that this is a 90-degree clockwise rotation. You don't necessarily have to put the around the origin part because for our class we're only rotating around the origin. But technically speaking, yes, it is around the point 0, 0. On the first two examples, I had you connect corresponding vertices. Let's see what happens when we do that for this one. P to P prime is this line, H to H prime is this line, and D to D prime is this line. Well, that's a hot mess. And you'll see that every time whenever you are performing a rotation, that the lines don't line up all nicely the way that translations and reflections do. So if you connect each of your corresponding points and they make weird crisscrossy disorganized lines, then it's a good chance that it's supposed to be a rotation. Another thing you can do to prove that this is a rotation is look at what happened to the pre-image points versus the image points. P, for example, was the point -7, 4, and P prime is the point 4, 7. So this rule that would match what we did here, well, I changed around the order of my numbers, so y became x and x became y, but I also changed the sign of my x value when I made it the image point. So the rule that would map P onto P prime is y negative x. And you can compare that to the rules of rotation that you should have memorized and see that that is the rule for 90-degree clockwise rotations. So as you can see, there's a variety of ways to identify what kind of transformation you're looking at. Just kind of depends on how it works best for your brain. So let's try another one. Well, looking at the orientation of these two shapes, P is on the left for the pre-image, but P is on the bottom for the image. H is on the top, but then it's on the right, and D is on the bottom, but then it's on the top. So you might be tempted to say that this is a rotation, because the orientation of my figures is so much different. But take a quick second to connect each of your corresponding points and verify whether they line up nicely or whether they crisscross in a disorganized fashion. P to P prime, D to D prime, and H to H prime, the segments that connect the pre-image points to the image points are all parallel to each other. That's indicative of a reflection, not a rotation. So you just have to figure out what line triangle PHD was reflected in. You might remember I gave you a little bit of a cheat code for this class because for diagonal lines of reflection, the only one that we're going to use is y equals x. We're not going to reflect over any other diagonal lines. So since the segments that connect the pre-image and the image are diagonal, the line of reflection must have been the line y equals x. That purple line is perpendicular to the red lines. So my answer here would be that this is a reflection in the line y equals x. Our next transformation looks pretty similar to the one that we just discussed, but it is a little bit different. It's similar because the orientation of the image and the pre-image are different from each other. P was on the left for the pre-image, but then P prime was on the right. H was on the top for the pre-image, but H prime is on the bottom for the image. And D was on the bottom for the pre-image, and D prime is on the top for the image. So we're in a different orientation for the pre-image and the image, so it might be a rotation or it might be a reflection. An easy way to figure out is to connect each of your corresponding vertices. D to D prime, H to H prime, P to P prime, and I end up with all kinds of crisscrossy disorganized lines. So this must have been a rotation. It actually isn't completely disorganized though. Did you see where all of them intersect this time? They all intersect at the origin. And that's indicative of a 180-degree rotation. Alternatively, you can think about it as triangle PHD went 2 quadrants away. So that makes it 180 degrees because each quadrant is 90 degrees each. And remember that for 180-degree rotations, you don't actually have to say whether it's clockwise or counterclockwise because you would get the same thing either way. So let's try another one. This time I see that the pre-image and the image are in the exact same orientation. P and P prime are both on the left, H and H prime are both on the top, D and D prime are both on the bottom. This is looking like a translation. And I can confirm that by connecting my corresponding vertices. P to P prime, D to D prime, H to H prime. Those lines are parallel and they're the same length, so each of my pre-image coordinates moved the same distance and the same direction to arrive at the image. So to figure out my rule, I just have to count how far it went. Make sure you're counting from corresponding vertices, not like from D to H prime, just because those are the closest two vertices doesn't mean that that's where you count from. Instead, you should be counting from H to H prime, for example, or D to D prime or P to P prime. So the horizontal distance between H and H prime is 1, 2, 3, 4, 5, 6, 7 to the right. So that's a +7. And then I go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And going down is a negative motion. So the rule that I can write for this translation is x + 7 and y - 11. What do you think about our next transformation? The image and the pre-image are in totally different orientations, right? H was on top, but then it's on the left. P was on the left, but then it was on the bottom. D was on the bottom, but now it's on the top. So we're all over the place in our orientations. So that means that it's either a reflection or a rotation. So let's connect each of our pre-image and image coordinates and see if we have parallel lines or messy lines. Remember, parallel lines means that it's a reflection, and messy lines means that it was a rotation. So let's see, D to D prime, P to P prime, and H to H prime. Well, those are definitely not parallel, so this must have been a rotation. You might be wondering why the lines are so messy, and that's because that's not really how these points are related to each other. When you're rotating around the origin, in this case for 90 degrees, right, because it was one quadrant away, you should actually be going from the pre-image to the origin to the image and make a right angle as you do so. Let me show you what I mean. From D to the origin, and then from the origin to D prime, that's a right angle. From H to the origin, and then the origin to H prime, that's a right angle. And from P to the origin, and from P to P prime, that's a right angle. So that is yet another way that you can confirm that this is a rotation of 90 degrees counterclockwise. We're going in the opposite motion of what the clock does, so this would be a 90-degree counterclockwise rotation. On our next transformation, we have some similarities in our orientation, but it's actually like they're upside down from each other. P and P prime are both on the left, D and D prime are actually the exact same point, they're both on the right, but H is on top and H prime is on the bottom. So really, these two triangles are just a mirror image of each other, and that makes it a reflection. Another way that you can identify that it's a reflection is by connecting the corresponding vertices, P to P prime, H to H prime, and there's nothing really to do for D and D prime, right, because they're the exact same point. But looking at the two segments that we did get, they're parallel to each other, but not the same length. If they were the same length, that would be indicative of a translation, but since they're different lengths, it must be a reflection. And if you cut each of those red segments in half, you'll find the line of reflection. For example, P to P prime is 4 units, and half of 4 is 2. So if I count inward 2 units from both P and P prime, those arrows point at the line of reflection. This must be my line of reflection. But what's the equation of that line? Well, it's horizontal, so that means it must be a y equals equation. But y equals what? Y equals 2. So my description for this transformation would be that it's a reflection in the line y equals 2. Our next triangles are in the same orientation. They both have H on top, P on the left, and D on the bottom, so it's looking like a translation. But let's confirm it by connecting our pairs of corresponding points, P to P prime, H to H prime, and D to D prime. So each of those red segments that I just drew are the same length, and they are parallel, so that is indicative of a translation. To figure out how far it translated, we can count from a pre-image vertex to its corresponding vertex on the image. For example, from P to P prime, I go to the right 1. Going to the right is positive, so I went +1. And then I'll go down 1, 2, 3, 4, 5, 6. Going down is a negative motion, so that would be minus 6. So my rule would be x plus 1, y minus 6. And we're just going to go real quickly through this last set of examples. I won't explain everything quite as in depth, but let's look at some more to make sure that we understand what's going on. These two triangles are in an opposite orientation. C was on top, but then C prime was on the bottom. This looks like a rotation to me. In fact, if I connect my corresponding vertices, you'll see that they crisscross all over the place, but they crisscross in such a way that they all intersected at the origin. That's indicative of a 180-degree rotation. For our next example, they're in the same orientation. They both have N on the left and C on the top and T on the right. So it must be a translation, but how far did we go? Well, count carefully. Make sure you're going from the pre-image to the image. We went to the left 8 and up 8. So that's x minus 8 and y plus 8. Our next shapes are in a different orientation from each other, so it's not a translation. It's either a reflection or a rotation. The easiest way to determine which one it is by connecting your pre-image vertices to the image vertices and seeing if they are parallel, like these ones, or messy. These ones are parallel. Each of those segments are a different length, so this must be a reflection. And since the lines that connected the pre-image and image vertices are diagonal, we know that we must have reflected in this diagonal line, which is the line y equals x. We have another reflection for our next example. N to N prime, C to C prime, T to T prime. Those lines are all parallel but different lengths. Remember, if they were the same length, then it'd be a translation. But parallel and different lengths means it must have been a reflection. So you can cut those lengths in half to figure out where the line of reflection is. For example, from T to T prime is a total of 12 units, and half of 12 is 6. So if I count inwards 6 units up and down, those arrows point at the line of reflection, which must be the x-axis. So this is a reflection in the x-axis. The triangles in our next example are in a different orientation as well, so let's connect our corresponding vertices and see what happens. C to C prime, N to N prime, T to T prime. That's a hot mess. Those lines are definitely not parallel, so they are not a reflection of each other. Therefore, this must be a rotation. Specifically, it's a rotation of 90 degrees, because I went basically from one quadrant to the next, and counterclockwise. Remember, this is the triangle where we started, and we moved in this direction to get to the image triangle. That is opposite of the way that the clock moves, so that would be a counterclockwise rotation. Remember, the other way that you can think about this as being 90 degrees is by going from a pre-image coordinate to the origin, and then the origin to the image, and that should make a right angle. So no matter how you think about it, this should be a 90-degree counterclockwise rotation. For our next example, it looks like we have a translation because they're in the same orientation. N to N prime, C to C prime, T to T prime. Those lines are parallel and they're the same length. So this must have been a translation. So to figure out how to write the rule for that translation, you just count the distance between corresponding points, like from C to C prime. Those are exactly 11 units away vertically, and you didn't have to move it all horizontally, so the rule that we would write is x, y plus 11. Our next transformation looks a little crazy because it's all crossed over on top of itself, but the same properties still apply. Let's look at these segments that connect the pre-image to the image for each of these. And those lines are parallel and different lengths. That's indicative of a reflection. So you can find the halfway point along each of those red segments to figure out where that line of reflection is. For example, from C to C prime is a total of 6 units, and half of 6 is 3. So I can count in 3 to the left and to the right, and that is pointing at the line of reflection, which is not an axis this time, it is this line right here. And the equation for that line, since it's vertical, it must be an x equals equation. Specifically, it would be x equals 1. What do you think about our next one? We're in a totally different orientation, so it's definitely not a translation. Could be a reflection, could be a rotation. Let's connect our points and see what we get. Well, we get lines all over the place. So this must be a rotation. The triangle traveled basically one quadrant away, so it's a 90-degree rotation, and it traveled in the direction of the clock. So that would be a 90-degree clockwise rotation. And let's end with an easy one. These are in the same orientation. C to C prime, T to T prime, N to N prime are parallel and the same length. This must have been a translation. To figure out the rule, you count the distance between C and C prime. To get from C to C prime or from T to T prime or N to N prime, we go to the left 1, 2, 3, 4, 5, 6, 7, 8, 9. And going left is a negative motion, so that's -9. And then I go up 1, 2, 3. Going up is a positive motion, so that's +3. So I would say that this is a translation using the rule x minus 9, y plus 3. And that's the basics of what you need to know about how to identify what kind of transformation you're looking at when they've been graphed in the coordinate plane. In our next lesson, we're going to combine multiple transformations into one, which creates something that we call a composition of transformations.